What helps us to remember and forget things? What are the processes and mechanisms involved in remembering or forgetting things? The ability to remember is a wonderful gift given to animals and mankind, but once it fails us, we can become very miserable and almost useless. Our quest to understand the underlying science of forgetfulness led us to investigate and develop this research-based documentary. Memory is an essential aspect of human cognition, allowing us to learn from experiences, store information, and navigate daily life. Yet, forgetfulness is a common experience that can range from minor inconveniences to significant challenges affecting quality of life. Understanding the biological, biochemical, physiological, pharmacological, and chemical foundations of memory and forgetfulness can illuminate why we forget and how we can improve our memory. This video aims to explain these complex processes in simple terms, making the science accessible to everyone. The biology of memory. At its core, memory involves the brain's ability to encode, store, and retrieve information. These processes occur within the intricate network of neurons, the brain's nerve cells, that communicate through electrical and chemical signals. The encoding phase is the initial learning of information, where sensory input is converted into a form that the brain can process. Storage involves maintaining this information over time, encompassing both short-term, working memory and long-term memory. Retrieval is the process of accessing stored information when needed. Key brain regions involved in memory include the hippocampus, which is crucial for forming new memories and connecting emotions and senses to these memories. The prefrontal cortex, involved in working memory and decision-making, and the amygdala, which links emotions to memories, particularly those associated with fear and pleasure. The biochemistry of memory. Neurons communicate via synapses using neurotransmitters, chemical messengers that transmit signals across the synaptic gap between neurons. Neurotransmitters involved in memory include glutamate, essential for synaptic plasticity, the ability of synapses to strengthen or weaken over time, which is crucial for learning and memory. Acetylcholine is important for attention and learning, and reduced levels are associated with memory impairments. Dopamine is involved in reward-based learning and motivation. Synaptic plasticity, particularly long-term potentiation, LTP, is a key mechanism underlying learning and memory. LTP is a long-lasting enhancement in signal transmission between two neurons resulting from stimulating them simultaneously. This process strengthens the synaptic connections, making it easier for neurons to communicate in the future. Why do we forget? Forgetfulness can be attributed to several factors that interfere with the encoding, storage, or retrieval of memories. One explanation is the decay theory, where over time unused memories fade as neural connections weaken if not reinforced through recall or rehearsal. The interference theory suggests that old memories can hinder the formation of new ones, known as proactive interference, or new information can cause forgetting of old information, known as retroactive interference. Retrieval failure occurs when memories are stored but not accessible due to lack of retrieval cues or ineffective encoding. Emotional factors such as stress and anxiety can impair memory formation and retrieval by affecting the hippocampus and prefrontal cortex. High levels of stress hormones such as cortisol can disrupt neural processes involved in memory. Physiological factors like sleep deprivation disrupt memory consolidation, the process where short-term memories are transformed into long-term ones during sleep. Nutritional deficiencies in essential nutrients such as vitamins B6, B12, and folic acid can also affect brain function. Aging naturally leads to reduced neuroplasticity and neurotransmitter levels, impacting memory. Medical conditions such as Alzheimer's disease, depression, and thyroid disorders can cause memory impairments due to changes in brain structure and function. Improving memory strategies and scientific basis. Engaging in regular mental exercise, such as puzzles or learning new skills, stimulates neural connections and promotes synaptic plasticity. Mental challenges encourage the brain to form new neural pathways, enhancing cognitive reserve. Maintaining physical activity improves blood flow to the brain and stimulates the release of growth factors that aid neuron health and neurogenesis in the hippocampus. Prioritizing quality sleep is vital for memory consolidation. During sleep, the brain processes and organizes information, transferring it from short-term to long-term memory. Adopting a balanced diet rich in omega-3 fatty acids, antioxidants, and vitamins supports synaptic function and protects neurons from oxidative stress. Foods such as fish, berries, nuts, and leafy greens are beneficial. Using mnemonic devices like acronyms or visualization aids memory by enhancing encoding through associations and engaging multiple areas of the brain. Managing stress through relaxation techniques lowers cortisol levels, which can otherwise impair hippocampal function. Practices such as meditation, deep breathing, or exercises can be effective. Staying socially active stimulates cognitive function and can delay memory decline. Social interactions challenge the brain and improve mood, both of which are beneficial for memory. Organizing information by breaking it into smaller chunks reduces cognitive load, making encoding more efficient. This technique, known as chunking, helps in remembering complex information. Repeating and rehearsing information strengthens neural connections, making retrieval easier. Repetition reinforces the memory trace in the brain. Limiting multitasking allows full concentration, enhancing memory formation. Focusing on one task at a time reduces distractions and improves the depth of information processing. Pharmacological aspects. Certain substances can influence memory. Caffeine can enhance alertness and concentration in the short term, but should be consumed in moderation to avoid negative effects like anxiety or sleep disruption. Medications such as cholinesterase inhibitors increase acetylcholine levels and are used in conditions such as Alzheimer's disease to improve cognitive function. Herbal supplements such as ginkgo biloba are believed to improve blood flow to the brain, potentially enhancing memory. However, scientific evidence is mixed, and it's important to consult a healthcare provider before starting any supplement to avoid interactions with other medications or side effects. Understanding forgetfulness in everyday life. It's important to recognize that occasional forgetfulness is normal and can result from temporary factors including stress, fatigue, or overload of information. Strategies such as writing reminders, setting alarms, and creating routines can help manage everyday forgetfulness. However, persistent memory problems that interfere with daily functioning warrant professional attention. Difficulty performing familiar tasks, frequent repetition of questions, and confusion about time or place are signs to seek help from a healthcare provider. Conclusion. Memory and forgetfulness are complex phenomena rooted in the brain's biology and influenced by various factors ranging from biochemical processes to lifestyle choices. Forgetting is a natural part of life, but understanding the underlying mechanisms empowers us to take proactive steps to enhance our memory. By engaging in mental and physical activities, maintaining a healthy lifestyle, and employing effective memory strategies, we can improve our ability to remember and enrich our cognitive health.